Welcome to today's lesson. So we still continue looking at partial fractions. So we're still looking at the tutorial questions, and tonight we'll proceed. We're looking at repeating factors and also quadratic functions. Partial fractions that have repeating factors, and then also those that have quadratic functions that can be factorized. That is exactly what we're going to look at tonight. All right, so we have these questions here. And in case you have any questions or you want to join tuitions, you can simply just use the contacts on the screen right now and send me a text message, or if you have any question, you can send to these same lines on the screen, and then I'll respond as soon as I see your question. All right, so let's quickly look at the questions that we have. So when you look at the first part here, sorry for that. So this first part here is a factor, and this is a linear factor. So since it's a linear factor, its corresponding partial fraction will just be a over, let me use white. I don't know which color can be seen on both white and green. Okay, let me just use the same white. So the first factor that we have is a linear factor. So its corresponding partial fraction will be a over, okay, let me just do this. So let me just write this. So we have 9x squared and minus 58x minus 37. Then we have everything divided by x plus 7, then x minus 2 squared. So we write the corresponding partial fractions for this expression. So how do we write that? So the first one here, we have a linear factor. So for a linear factor, we're going to have a, like we learned. So it's just going to be a over x plus 7. Then the second part here is also a linear factor, but this one is repeating itself. How many times? 2 times. So how do we deal with that? So we say plus b over x minus 2. Then since it's repeating itself 2 times, then we have to also add c there, which is going to have the same factor, but in this case, it's going to have the squared there. So here it's just a matter of finding the common denominator. Yeah, after finding the common denominator, you look at the factors. I mean, you compare the coefficients, or if you don't want to compare the coefficients, you can find numbers that can make or that can eliminate certain terms in the expression. So let's quickly proceed to what I'm trying to talk about. So the next step here, we're going to copy that same expression there. This is what we're going to have. Then everything over, the first factor we have is x plus 7. And the second factor we have is x minus 2 and squared. And we say this is equal to, so here I'm going to find the common denominator. Remember what I told you? The common denominator is normally what is here. So here we have what? We have x plus 7 and x minus 2 squared. So we say this, or we start with this one, this part into this expression, the common denominator, means that this and that will cancel, will just remain with this part. So this part times a, we're going to have a times x minus 2, then close brackets squared. And we say plus this into this expression here. We're going to cancel this part. In here we have 2 of this. So meaning this one will cancel with 1 of itself there. It will cancel with it 1 of its kind in this expression. And we'll just remain with one function, which is like this one and that one. And then we'll multiply it to b. So we're going to have something like this, b, then x plus 7, then multiplying x minus 2. Then from there, we say plus. Then when you say this expression into this expression, means that this whole part is canceling with that. And you're just going to remain with this expression. So this expression times c there, you have c times x plus 7. So now here it's just a matter of finding the values of a, b, and c. So how do you find that? So the first thing that you need to understand is that mathematically, this and that will cancel. So we're just going to remain with 9x squared minus 58x minus 37. Then this will be equal to a, open brackets, we have x minus 2 squared. And then we have plus b, open brackets, x plus 7 and x minus 2 there. Then we also have plus c there, open brackets, of x plus 7. So this is an expression that we're going to use to find the values of a, b, and c. So like I said, there are two methods you can use to find these values. The first one is by trying to look at the numbers that we can replace either here, the numbers that we can replace with x to make two of these terms to become zeros and just remain with one term. And then the second method is the one that, that we say we compare the coefficients of terms. So let me start with finding a number that I can replace where there's x there to make two terms, to make two terms in this expression to be zeros. So if I put 2 there, I'm going to have 2 minus 2, that will be a 0. 0 times a means that this whole part will be a 0. But if I put 2 there, this will also be 2 minus 2, which will be 0. 0 times everything there, that will be 0. So if I take x to be what? To be 2. It means that this part and that part will be what? Be zeros. We'll just remain with this expression there. So what this means is that we have to replace the 2 on both sides, this side and also this other side. So this side we're going to have 9, then we'll put 2 there, and squared minus 58, 2, then minus 37. Then we say this is equal to, here you put 2, this becomes 0. If you put 2 there, the whole expression here becomes 0. So when you put 2 there where there's x, you're going to have c outside, and then you have 2 plus 7. So here we're going to have 2 squared, that will be 4. 4 times 9 will get 36. Then we have minus 58 times 2. So 58 times 2, you have 6 there. And then 8 times 2, that will be 6 there. Then 8 times 5, that will be 10. Plus 1, that will be, it should be 116. Yeah, and then we have minus 37. Then we say this is equal to 2 plus 7 there. That will give us a 9. Then we have a c there. So 36 minus 37, the answer will be -1. -1, okay, sorry for that. Okay, so 36 minus 37, that will give us -1. Then -1 minus 116, that will give us -117. Then this will be equal to 9c. So we divide by 9 on both sides. Divide by 9 on both sides. Then when you divide by 9, you discover that the value of c is simply just going to be what? 13. So we do the same even for these other values of a, the values of b and a. So if I want to eliminate this expression there, since I already found c, meaning I can eliminate c, I can also eliminate any part that contains x plus 7, which is b. So how do I work out such an expression, or what value can I use there to eliminate what? To eliminate this and that. So if you check, if I put -7 where there's x, if I say let x be equal to -7, means that here I'm going to have a 0, there I'm going to have a 0, 0 times this and that, it will still be a 0. So I'm just going to remain with that part. So this side, if I replace -7, what is x, I'm going to have 9, -7 there squared, minus 58, -7, then minus 37. Then we're saying this is equal to, this side, when we put -7, one there's x there, we're going to have a outside, then -7 minus 2, then squared. Then when we put -7 there, this would be a 0. 0 times everything, because -7 and 7, when you add them, they'll give you a 0. So 0 times everything here, this will be a 0. This is also going to be 0. So the next thing that you have to do is to do the multiplication. I mean, to simplify the expression that you've been given. So here we have -7 squared, which is 49. Yeah, so say 49 times 9. 49 times 9 will give you something like a 441. And then we say minus, okay, there's a minus there and the minus there to become positive. So when you multiply 58 and when you multiply 58 and 7, you're getting 406. Yeah, and then you say minus 37. Then this side you're going to have -7 minus 2. You are having what? -9 squared. So when you add 406 and 441, when you add 406 and 441, you get something like 847. Then when you subtract 37 from 847, you're going to get 810. Then we say this is equal to -9 squared will give us what? 81 times a. We'll have 81a. So over 81 over 81. So the value of a is simply just going to be what? 10. So it's very simple. This is how you deal with partial fractions. So now let us see how we can find the value of b. So the value of b, there's no way we can find anything that can eliminate this and that at once. Any number that can eliminate this and that at once, there is no way. So if there is no way to do that, what you just need to do is to simply just compare the coefficients. So I'm going to get the coefficients of x squared. So let me just erase the middle part. So I'm going to get the coefficients of x squared and then put them together, and then see what I'm going to get as the solution. So if you want, you can get the constants. If you want, you can get the coefficients of x. You still get the same answer as what I'm going to get right now. So here I'm going to get the coefficients of x squared. So on the left, we have the coefficient of x squared here. We have 9. And then this other side, when you check the first term here. So on the first term, the coefficient of x squared. So when you simplify this expression, you have something like x squared minus 4x plus 4. So the coefficient of x squared is 1. 1 times a, we're going to get what? A. And then we move on to this expression, the next one. So the next one here, on the next one, when you simplify this expression, you're going to get x times x will give us x squared. Then you have x times -2 and x times 7. When you add them, you get something like positive 5x. And then when you multiply 7 and 2 there, and -2, you're going to get -14. So the coefficient of x squared here is what? 1. It's simply just 1. 1 times b, the answer is what? Is b. We move on to this expression. What is the coefficient of x squared here? We don't have. So if we don't have, we don't need to write anything. So now, we already have the value of a. So the value of a there is 10. So we are just going to replace what? The value of a there. Then we say plus b. Then from there, we'll take this to the other side of the equal sign so that we have the value of b as 9. minus 10. So the value of b will become -1. So the partial fraction will therefore be decomposed. I mean, this expression here will therefore be decomposed into its partial fractions as, so while there is a there, you write the value of a there. So you're going to have 10 there. Then while there is b, you're going to write the value of b there. And that is going to be, b has been found here to be -1. So we can write a -1 there. So we write negative there and then 1 on top. Then while there is c there, we also put the value of c, which is 13. So this is the solution for the first question. So I believe the same way I've solved the first question, that's the way you solve the second question. So the same way I've solved G, that's the way you can solve H. So in case you solve H and then you're still doubting your answer, you can simply send the answer to my WhatsApp line and then I'll check whether you are wrong or correct. Okay, so let's move on. Let's see how we can deal with part C. Okay, so C is -7x² plus 108x minus 11. Then we're saying everything is over. We have x, open brackets, x² minus 9x plus 1. So the first thing that you need to check here is whether or not you can factorize this quadratic function there. Okay, so this is what you have. So when you check this one, can we factorize this? Okay, let's try. So we can try. Let's try to find factors that we can add to get -9. And when we multiply them, they'll give us 1. Is it possible to have a number after multiplying, you get the product as 1, then after adding, you get the same as the sum as -9? Is it possible? When you add those two numbers, you get -9. When you multiply them, you get 1. So it's nearly impossible. So what do you do with that? It means that this expression cannot be factorized. So if you can't factorize the quadratic expression, remember what we said. So the first term that we have here is x. So this one we're going to have a over x. But the second term is a quadratic equation that cannot be factorized. So we say bx plus c. And then everything over the expression. So the expression is 9x plus 1. So now, how do we finish up this? How do we deal with this? So this is very simple and straightforward. So we do the same, we find the common denominator on the right. So let me copy what is on the left this side. So we have -7x² plus 108x minus 11. Then everything over, we have x² minus 9x plus 1. Then this is multiplying with x outside this side. Then this side, what we have is, you find the common denominator. Remember what I told you, the common denominator is usually what you have there as the denominator. So the common denominator will therefore be x, open brackets, we have x² minus 9x plus 1. And then we say x into this expression. When you, it means that we're just canceling this x and that x will remain with this expression there. So this expression times a, we're having a times x² minus 9x plus 1. Then we say plus. Then we say this expression into this expression will just remain with what? X. X times what is on top there. So we're going to have bx plus c, and then open brackets and close. Then you open times what? Times x. So if you want, you can just write x like that. Then, like I said, mathematically, this and that will cancel. So if you want, you can do the cross multiplication, you discover that this will come and cancel with that. And you just remain with 7x squared plus 108x minus 11. And this will be equal to a x squared minus 9x plus 1. Then plus bx plus c. And then you have this x. So now the next thing here that you need to do is to find the values of A, B, and C. So now in such a situation, you don't need to find a number that will cancel the other term, meaning you only have one option, which is comparing the the coefficients of various terms here. So how do you compare the coefficients? So if I said if I take, for instance, that I'm comparing the coefficients of what? Of x squared. If I compare the coefficients of x squared, this side I'm going to get -7 is the coefficient of what? Of x squared. Then here, a times x squared, I'm getting what? Ax squared. So the coefficient of x squared in this expression is what? Is a. So I'm just going to say is equal to what? A. And then here, the coefficient of x squared will be found by multiplying this x times bx, because bx times what? Times x will give us what? Bx squared. So the only coefficient that we're going to have for x squared in this term is what? Is b. Because when you multiply c and x, you get what? Cx. Cx is not I mean, this x is not raised to the power 2. Hence, the only coefficient of x squared that we have is b. So we're going to say plus b there. Then from there, we'll consider this as our first equation. Then we can also compare the coefficients of what? Of x. So when you compare the coefficient of x on the left, this side, you're going to have 108. So 108 is the coefficient of x. Then here on the right, you're going to have a times -9 there. So a times -9 will be the coefficient of x. So we say this is equal to a. So the coefficient of x is going to be -9a rather. So we're going to have -9a there. -9a, because when you multiply a times -9x, you have -9ax, and the coefficient of x is what we're looking for. So we get -9a. Then here we also get the coefficients of x here. So if you multiply, like I told you, if you multiply this expression times x, you are going at one point you have cx, which I wrote here. So meaning the coefficient of what? Of x will be what? Will be c. So I'm going to write plus c there. So we have our equation 2. Let us also compare the coefficients of, the constants. We compare the constants. So on the left, the constant we have is 11. Then on the right, the constant that we have is what? A times what? A times 1. So we're just going to have a. Then do we have a constant in this expression? No, because when I simplify this expression, I'm going to get b. B times x, bx times x will be bx squared. C times x, this will be cx. So I'm not going to have anything that is a constant, meaning something that does not have x. So will not have anything. So this gives us the value of a. So the value of a is what? Is 11, is -11 rather. So I'm going to replace a there and there to find b and c. So in the first equation there, I'm going to have -7 being equal to, while there is a there, I'm putting -11, and then I'm going to say plus b. So these will cross the equal sign, and I'm going to have 11 -7 is equal to b. And finally, I'm going to have 11 minus 7, and that will give us what? 11 minus 7, that will give us 4. So meaning the value of b is simply just equal to 4. And then the other thing is, to find the value of c, we simply just replace the value of a there. So we're going to have 108 this side, and then we say -9 times negative 11 because A has been found to be negative 11 there. Then we say plus C. So when you multiply there, you get 108 this side is equal to 99. 99 plus C. So this 99 will cross the equal sign and it will become negative 99. And this is going to be 108 minus 99 is equal to C. So when you subtract 99 from 108, you're going to get 99 from 108, you're going to get 9 as the solution. So the value of C is simply just what? 9. So the value of A is negative 11, B is 4, and C is 9. So to write your final answer, you just have to replace the values there. So the value of A is negative 11. So we'll put negative 11 there. So we have negative 11. The value of B is 4. So we put 4 there. And the value of C is 9. So we put 9 there. So I'm just going to do this. So this is the final answer. So it's not difficult. This is a very straightforward question. Whenever you meet partial fractions, this is something that you should always be feeling nice to solve. If you meet a partial fraction in an exam, this is a free mark. You just have to always count it as a free mark. All right, so let's quickly move on to the next question. So we have these questions, and I believe I've shown you how to solve a partial fraction which has a quadratic equation that cannot be factorized. So when you look at the previous question that we solved here, this one, and this one, they're just the same. You can't factorize this quadratic equation there. So you simply just follow the same steps that I did here. And then I'm just going to solve one of these. Maybe let me pick this one. Yeah, let me pick this one. Then we call it a day so that next time we meet to just start matrices. So we have 2 minus 11x. So the questions that I'm leaving, you can take them as your exercise, then do them. So if you do them, in case you are doubting your solution, you can simply just forward it to my WhatsApp, and then I'll confirm if it's true or if it's wrong or correct. So we have 2 minus 11x, then we have plus x squared minus 7x cubed. Then everything is being divided by x plus 2 squared. So we have x squared there. So what you have inside there has the power 2, which implies that it's a quadratic equation. But when you check this quadratic equation, this cannot be factorized. So if you can't factorize this quadratic equation, it means that you have to write something like this. So on top there, you have a x plus b over x squared plus 2. But this one is repeating itself. So now how do we deal with that? So if it's repeating itself, how do we deal with that? So you have a plus there, and then you get your cx, then plus d, then everything over. We have x squared plus 2, then raised to the power what? To the power 2. Okay. So now, having done this, the next thing that we do is now finding the common denominator. And the common denominator is simply just this part. So I'm going to copy the same thing that we have here. Then we say this is equal to, the common denominator is simply just what we have there. So I have x squared plus 2, then squared. Then you say this into that, you just remain with one of this kind. Hence, you multiply it with the numerator there. You are going to have ax plus b multiplying with x squared plus 2. Then you say plus this into that, it's 1 times cx plus d. We're just going to have cx plus d as the solution there. So from there, on this side, I forgot to put the common denominator, which is x squared plus 2. So from there, what we do, like I said, this and that will mathematically cancel, and you are just going to remain with 2 minus 11x plus x squared minus 7x cubed. Then everything being equal to ax plus b, then you have x squared plus 2, then plus cx plus d. So now, after having this, like I said, if you have nothing that you can cancel out, if there's no number that you can replace where there's x, in order to cancel the other terms so that you find at least one unknown number there, the only thing that you resort to is comparing the coefficients. So if we say we compare the coefficients of, if we say we compare the coefficients of x cubed, so this side we're going to have -7. So this side will have -7. And then this other side, for you to get x cubed, you have to multiply ax and x squared there. So ax times x, you get what? Ax cubed. So the coefficient of x cubed, this side is what? Is only a. Because there are no other terms that you can multiply this side to get what? To get cubed. Yeah, so it's only this part and that part. So we have this a there. So this other part here, so this part, yeah, so this other part, in this part, there's no way we can get the coefficient of what? X cubed. Yeah, the highest power we have here is 1. So we can't get that. So we just leave it. So this tells us to say the value of A is what? Is -7. So now let us find the value of B and C and D. Yeah, so how do we do that? So let us try to compare the coefficients of the constants. So we can also compare the constants here. Yeah, so you always take something that is as simple as possible. So I know to say the constant this side I'm going to have 2. Then this side, for me to get the constant, I think the only way I can get the constant is by multiplying b and what? And 2. So I'm going to have 2b. And then in this expression, the constant is only d there. So we say plus d. So I don't have the value of b and d. So I'll mark this as my equation 2. This one was my equation 1. So let us also try to compare the coefficients of what? Of the coefficients of x squared. So the coefficient of x squared, this side we have what? We have 1. Then on the right, this side, if you want to find x squared, you can multiply b times x squared. You're going to get what? Bx squared. And then the other thing that you can do here to get x squared, do we have any way we can get x squared in this S? We don't have. So what does that mean? The only coefficient of x squared that we have, this side, is b. So I say this is equal to b. So this tells us to say the value of b is what? The value of b is 1. So we found the value of a. We've also found the value of b. So now we can replace b there to get the value of what? D. So we have 2 there, and then we have this being equal to 2. You put your 1 there as b, then plus d. So meaning when these 2 crosses the equal sign, you are going to get your d as what? As 0. So we have found A, B, and D. Let us now find what C is. So to get C, we're going to get the coefficients of what? Of X. So the coefficient of X this side is what? Is -11. So we write -11 there, and this will be equal to the coefficients of X on the right. Let me just remove these. Okay. So now the coefficients of X on the right. The first one that we have, or the first one that we can get, is by multiplying ax and 2, so that you get what? 2ax. So this is one of our coefficients of x. So we have 2a as one of our coefficients. Then the other one can be taken from what? we want the coefficient of x. So the other one can be taken from, so on this one, that's all. We don't have anything that can be taken from there to get the coefficient of x. Okay, we move on to the next term. So this term here, we have cx there. So the coefficient of of x there is what? Is c. So you just say plus c. But we have the value of a there, which is what? -7. Yeah, -7. So we're going to have -11 being equal to 2, then -7, then plus c. So this is going to be -11 being equal to -14 plus c. Then -14 will cross the equal sign, and you have -11 this side being sorry, that will be -11. Then this is going to be plus 14 is equal to what? C. So when you add this, you're going to get the value of C as 3. So this is the value of C. So we have the values of A, B, C, and D. So to find the final answer, it's just a matter of replacing them there. So the final answer will be, while there's A there, you put while there's A, you put -7. Then while there is B, we're putting what? 1. So while there is B there, we put 1. Then while there is C, we put 3. So we put 3 there. Then while there's D, we're putting 0. So putting 0 there is just the same as just deleting that. So let me put the 3x properly. Yeah, so this is the partial fraction that, these are the partial fractions for this rational function that we've been given. Yeah, so it's a simple, like, I don't know. Okay, it's just simple. Yeah, this is very simple. It's not something that you even need to spend months for you to know. These are straightforward. Yeah, so partial fractions, the most important thing that you need to know about partial fraction are just the standards, the basic concepts. How do, or how does, how does a linear factor look like into its partial fraction? How does a quadratic factor that cannot be, how does a quadratic factor that cannot be factorized look? How does it look? Or what does the factor that is repeating look like in terms of its partial fractions? So you just need to know that, that's all. Once you just know that, all partial fractions will be simple. And how do you know that, and where do you get that information? You can use John Bede Engineering Mathematics. Yeah, they have at least highlighted some of the most important points there. Then apart from that, you can also, refer to the video that we had at first before we started partial fractions. Before we started solving the tutorial questions. Yeah, so I made sure that I explained all those things that are required for you to solve partial fractions. So in case you've not watched that video, you can send me a text immediately after this lesson so that I forward you the video. All right, thank you very much. I don't know if you have questions before I can close the meeting. Okay. All right, so see you in the next lesson that we are going to have. Like I always say, if you have questions, these are the contacts that you can be using to reach me out. See you in the next lesson that we're going to have. My name is Hamted. Shalom.